Okay, so we get this problem x plus x minus 4 x plus 4 all that divided by x plus 2 plus x plus 3. Okay, so the to find the y-intercept for x, we have Mateo who is drawing.
Yeah,
And
sorry, it's kind of slow. I don't know why it's not showing, but
so yeah, so we have to replace every x value with 0 un until we have a number. So we replace x3 with 0. The same goes with 16 and the values in the denominator. So the result we get is 0 for the numerator and 6 for the denominator, but all the numbers divided by since we have 0, it's gonna be 0, so that's the y-intercept. The next one, set the bottom equal to 0 to find the vertical asymptotes. So the asymptotes are the values here. So we change the sign. It will be x minus x. The asymptotes will be -2 and -3. So yeah. Oh, I'm gonna erase that. So -2, -3. Top equal to 0 to find the x-intercepts. So while Mateo is drawing, we have here the numbers above are the x-intercepts. So we got x, which will be for this value will be 0. We change the sign here. For this value will be 4, and for this value will be -4. So we have these intercepts. We're gonna do also state whether the graph touches or crosses a ditch. We have to remind the multiplicity. If it's an odd number, it crosses and acts as line, but if it's even, it just touches the point but not crosses it and acts like a parabola. So we got here, all of these are 1, so all of them cross the x-axis. Okay, we did did
yeah,
this in
it's kind
the
of slow. I don't know
yeah,
why, but
we did this in the meeting before, because this is our third meeting. So all of these crosses, and now to find if it goes above or below. Mateo, would you like, or Scarlett, would you like to explain?
Yeah, I can explain. So we have to do this section. So here, like we put negative infinity -4, and then -2 and 0, 0 and 4, and then 4 to negative infinity. And so correct me if I'm wrong, but we have to do tests so we can do like the numbers in between or the left to the right to plug them in into the problem. Is that correct?
Mhm.
mhm.
And so like we put here on the test, we chose so because if negative infinity to 4, we can do -5. And so we will plug that in to the problem, which would be where the X symbol is, that's where we would put the negative. And so it would be -5, which it's negative, and then 5 again, and -4. And so with all of those negatives, this sign will be a negative, and that will be below because it's negative. And so we also do that with the bottom part, which is negative 5 plus 2, -5 plus 3. And sorry, we actually divide the sign that we get in the top with the sign that we get in the bottom. And
Yes.
that's how we divide those two signs, and that's how we get the final sign. Did that make sense, guys?
Yes.
Confusing me.
So
Okay.
yeah, we're replacing those numbers and
Yeah.
that's the sign we get.
And so that's how we do it with all of those. So with the test, we have to plug in the -1 with all of these, and how we did the graph here, that will give us the positive. And then again, we plug in the one where all the X, the symbol is, and then that will give us the negative, as well as with the 5, which is the positive. And that's where we know where the line will cross, which is below, below, and above again.
We did this because it was easier instead of the line. So if we want to use the line, we will put this values here. Here is 0, -2, -4, and negative infinity. And here will be 4 and infinity. We actually prefer this version because it's easier for us to see if it's above or below because of the sign. But yeah, so determine if the graph has an horizontal slant. Something we did is we divided.
If you want, I can explain a little bit about that one.
Yeah.
But basically, it's a division of like a polynomial division of long divisions. And we took basically the numerator for the first polynomial we received and divided by the denominator. So that's what we see in the screen is basically like a little sum up of the division. And we got that the asim is a slant of -5, which is gonna give us a positive 5 if we are gonna graph it. How do we know if it is actually slant? It's because the difference in powers from the numerator, the biggest power is 3, and for the denominator, the biggest power is 2. And because it's a difference of just one power, that give us the clue that this is a slant. So it's gonna be like a not vertical, sorry, diagonal line that's gonna cross uh, on the point of 5 if we're gonna graph. So basically, what we have there is just the sum up of the division. But yeah.
And yeah, that's how we got it. Here we got x minus
And
3x.
I'm
So
gonna pick up my charger because
we
it's
use
about.
we use a synthetic division to know to find the slant. So that's how we got it. This is like the simplified version, but here we replace the values and well, we ignore this number, and that's how we got it. Well, the x doesn't go here. That's how we got it. And find where the graph crosses the horizontal slant asymptote. Well, we multiply this number with the numbers here. So x minus, well, with -5 plus the asymptote, we got -10 and -15. So we kind of here, we're guiding. So we have to remember that this goes below above, below, and above, so BA, BA. And we remind that we have our intercepts here. So we start drawing our graph. We know that all of them cross because the multiplicity 1, we put our intercepts here that we mentioned here for -4 and 0. The y-intercept is for all of them 0. Here we have mentioned also where the slant crosses, and our vertical asymptotes. Oh, we're missing one. Our vertical asymptotes, it's -2 and -3.
Mhm.
Oh, no, wait, 1, 2, 0, 1, 2, 3. Okay, we're missing one here. So we have 2 vertical asymptotes. And yeah, we also then if it was above or below, it was BA, BA. It starts below. Then from this range, from here goes above. From here goes below, and from here to the infinite goes above. So that's how we got it. Now we're going to do number 2. Mateo, could you later draw the intercept, the vertical symptom here, please?
Mhm.
Okay. Okay. So now we got this, and the process is kind of similar. So oh, oops, sorry. Here. We got 3x plus 1 multiplied by x minus 2 and x elevated 2 plus 1. So plug in 0 to find the x, to find the y-intercept. We kind of do the same thing. So we're gonna replace it. I'm gonna draw it first, and then Mateo will do it more
It's
organized.
basically I'm drawing, but it takes like 5, maybe 10
Yeah.
seconds to show up.
Yeah. Okay. So we are going to divide, multiply, sorry, everything by 0. We got -2 plus 1. So the y-intercept, correct me if I'm wrong, will be -2. Okay.
It's kind of slow, but yeah, yes. Yes.
Okay.
Yes. So basically it's gonna be 0 for x. When x is 0, y is -2. That's the direct answer right there. Let's see if
Okay.
it shows up. But yeah,
Then we have to find all the intercepts. So we have here intercepts will be -1/3, 1/3, and 1 over this.
so
Wait. Oh, here. Oh, no, no, no. Never mind. Never mind.
sorry. So but basically we are just gonna, let's
Will
see,
we just change the signs there?
Mm-hmm.
change the signs.
So it would just be -1, right?
Hey, wait a minute.
Yes. Well, first of all, it touches the graph touches set the top equal to 0. So basically it would be 3x plus,
Or -1/3?
Yeah, my will be 1/3 and
0?
2. That
Oh,
will
yeah.
be the x value. Okay, Mateo will draw it better. So I'm gonna
yeah.
delete this. The vertical asymptotes, my first time seeing x squared plus 1. Oh, to find
Sorry. 1/3.
okay. Set
I
the
don't know.
bottom to find the vertical asymptotes. So wait. Just to guide ourselves from the okay.
They come
So
from the bottom, right? So
x
Quadrado
2 at the power of 2 plus
minus
1 equals.
So there's no vertical. Oh my gosh, sorry, I'm trying to draw this, but I'm on my laptop and I can't. So we have this value, which will be
Yeah.
x2 equals 1, and x is square root of -1. So this cannot happen. So there's no vertical asymptotes here.
Yeah, I don't know what is now showing up, but
Okay, yeah, okay,
uh,
there we go.
should now it's showing up.
Yeah,
So basically there is not.
not vertical.
You cannot have like a square, negative square
Mm-hmm.
of something. So this one is not.
Yeah.
You will see the not in a couple 20 seconds if this allows us.
Okay. Can you make what is it called? Un cuadro.
The square. And
As
there you go here. Let me
of
go to
log
my
so we can choose our values. So we have the range here. Well, not the range, but so our values need to be from negative to 0. Oh, sorry, my mistake.
you want to put it in the line, maybe?
Yeah. Oh, thank you. Here's a 0.
How many do we want?
Oh, here we're missing x. It's
0.
2.
How many like
Um,
spaces in the table do we want for this?
4. I think 4.
4 by what? For length 4 by
4
4 by
by
4.
um
I think the previous
4.
one.
4 or 4. Yeah, it's okay for 4. So we have the 0 here. Um I'm gonna delete this later. The 0. We got minus 1/3. We got here negative infinity, positive infinity. What else? We got 2. So this we need to pick the values from here, then from here, from 0 to 2, and to 2 infinity. Could you draw that, please?
Um,
X equal to just do here.
so you mean drawing the
Uh-huh. Drawing while I draw, so it's
permanent?
so
Okay.
it's because
Let me
my
see.
my pen is from the Zoom, so it doesn't
Okay, on the
yeah. Oh, but we can put it later. I'm just gonna take a picture and I can put it later. We can put it
Sorry, this is kind
better.
of slow. Let me stop updating changes.
Yeah,
Okay.
take a picture.
Negative, negative, infinitive,
I know.
negative 1/3, 0 to infinity. Okay.
Yeah. I'm gonna delete this and then we can put it
Yeah.
Okay, so we got
Do -1.
oh yeah. Okay.
Okay. So we are putting in the first square negative infinity.
Was 1/3. Oh, which
Uh,
one was it?
Wouldn't it be between?
1/3.
Yeah, 1/3.
Okay. It's gonna show up in a little sec. No, no, number two is
Oh,
negative 1/3. But what's the other one?
2.
Mm,
Oh,
for
I'm missing
two,
this one. Okay, well, I put one
perfect.
extra. It's my bad.
And
The
the
other one,
next one is gonna be 2 to infinity.
yes. Okay.
Okay, so we don't need the last one, right? Without those ones are good. You are gonna see them in like 3 seconds because this really slow.
Okay, there you go. Yep. Don't forget to put here, Mateo, the x equal 2 because it's also an intercept.
Okay, x is an intercept and that's equals to, okay.
Okay.
And I show up in just 2 seconds.
The 0
All
was
right,
just to guide us, but it's not included. My bad.
perfect.
Um,
So what are the test numbers that we are going to use?
So in there we can do -1, I think, on the for the negative infinity to 1/3.
Okay, -1. It's gonna show up in 10.
Oh, you can
Then
you can write the function so we can do it quickly. I'm gonna write it down on my notebook.
Okay.
Plus
And
1.
we can do 0 maybe.
above, below. Uh, 0 for -1/3 and 2,
Yeah.
right?
Then
Okay,
for the other
perfect.
one we can do 3.
Okay, perfect.
Okay.
And you
So,
write it down to
0 and 1, 2. Okay, good. Okay,
perfect.
so gonna write here the
So, Ivana, could you just do the operation
yeah.
there because we are not gonna put it. We just put this signal, the signs.
Which operation should we use? This one or this one?
The operation to see the signs. So
Okay.
when x is equals to
This
-1,
one.
that's
but
negative.
that's the
Oh,
first
sorry.
problem.
Oh, I'm
That's the
sorry. I'm
first one.
sorry. So, oh, where is it? Where
So
is
we
it?
just have to change it, right, with
Yeah.
the x.
Yeah. So when 3 positive,
Okay. Let me try it.
we can do it from there, and I write the
Okay. I'm gonna
yeah. We can go up there, and I'm gonna write the results here. 3x
+1, x minus 2. So x2 minus +1. Oh,
-1.
this because the denominator x is elevated to 2, it will always be positive. +1 will always be positive. It doesn't matter if it's -1, -1 plus -1, it will be 1. So the denominator will be always positive. So I'm gonna put it here, positive.
Okay, so basically on top we have -1 minus plus the 3. No. Sorry.
Minus,
The
It's
3,
3x
yeah,
-1, right?
by minus negative
Yeah.
yeah,
by +1, negative,
minus,
right?
minus is
So the
positive.
first one is positive
Yeah, the positive's positive, and it would be above the x.
Yeah.
above.
So
So and it's gonna show up in like 3 6. So when
okay.
so the second one is gonna be 3
Zero.
times 0. That's a positive times positive for the one. It's gonna be positive and negative. So
Positive.
the second one is negative. On
Okay.
top we have, yeah. I don't know if it does make sense. I think I'm
Yeah.
jumping lots of
No, I
steps.
think that's
Good,
right.
good.
Yeah, that's good.
Okay, the
So
next
below
one.
the x-axis.
Perfect.
Minus 3.
For the three positive and positive, so basically it's gonna be negative on top because the first like parentheses are going to be positive plus the second parenthesis it's gonna be the last one is negative, so it's gonna be positive.
Wait, which one?
Sorry,
For the 3, right?
for the three. So yeah,
3,
right.
9, 10.
Positive, 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 it's
Yeah.
positive, positive, and then negative.
Positive, positive.
So both sections give you positive, right? So it would be above the x-axis.
Mm-hmm. Yeah. Okay.
Wait, I am confused.
Wait, which one?
So for the third one, is that what you're talking about?
Yeah, is it negative or positive?
Yeah, 3
It's
minus
yeah.
2, positive, 9, 10. Oh, it will end in 10 minutes. Oh my gosh. I'm gonna.
So it would be 3 and then times 3 positive plus 1 equals 10, which gives you a positive.
Uh-huh.
The
X.
3 minus 2 equals 1, which gives you a positive. So positive plus positive equals positive, right?
Uh-huh.
And then the
Positive.
bottom would be 3 squared plus 1 equals 10 positive. And so it's another positive. And so this one will be a positive and it will be above the x-axis. Did that make
Above.
sense?
Yeah.
Yep. So it's taking time to just load, but it's right there.
Okay. So now we're gonna wait. Okay, there you go. Determine if the graph has a horizontal or slant asymptote and then find that asymptote. So to find if the horizontal slant, we check here the coefficient and the degree. We see that they have both 2 as a degree. So they I think it's divided. Let me check my notes. Where is it? Where is it?
Yeah, so degree of numerator, it's 2 for the numerator, it's 2 for the denominator. Um,
Okay, I got it
so it's
here.
gonna be an horizontal
Yeah,
asymptote.
if they're equal, it's 3, and the denominator will be 1. So it will be something like if they're equal, it's then A N B M, and it will be like 3
Yeah,
1. Then the horizontal
be on the y-intercept.
asymptote
Because
will
so,
be 3. Yeah.
so let me see. That's E, right? So
And it doesn't have a slant because for a slant it needs to be the degree of the numerator needs to be 1 higher. So there's no slant.
doesn't let me to draw. How unfortunate. Oh my goodness, I hope this doesn't delete the thing. These kind of things are killing my little iPad.
Okay, so we can go drawing the slant as we go by. So
Y
there's
equals
no
3.
slant. When where the graph crosses the horizontal slant asymptote, we kind of do the same thing. Or we need to divide, wait. Oh, we need to divide. Um, we, um,
When the graph crosses the horizontal and the slab. So
We
this one is,
multiply that. Oh, sorry.
we can go drawing. Yeah.
let's see. Okay. So basically,
If, do we just set the whole like function equal to 3?
the whole function equal to 3 because that's the answer that we have, and we have to simplify things.
And so do we first just multiply both sides by the one that's below the x2 plus 1?
Okay, so let me write that down and see if that
I'm
makes
not quite sure
sense.
in this part,
So
so let me know if that's
3, I'm gonna put it down and see if 2, so this is what you were saying, x2 plus 1 equals 3. So we have to multiply both sides, which is gonna give us 3x2 minus 5x and minus 2, right? Equals 3x2 plus the 3 that we had on the result. I don't know if it's loading.
yeah, it's right there.
Does it make sense? Oh, have to improve my handwriting by the end of the semester.
It looks good. It's understandable.
Okay, and so then, oh my gosh, I don't know
Yeah,
why
that's
it's
right.
blank. Sorry, I have to go back again. But sorry, you can talk while I'm loading this again.
And so on this side, do we just, I'm just,
We divide.
or do we subtract it?
Well, we
We
can
have to
subtract.
simplify it first. So basically here, what we can do is delete the 3x2 from the right and from the left because it would simplify. So I did that, and then we're gonna have a negative 5x minus 2 equals the same positive 3.
Mhm.
And then we are just gonna pass the 2 over to the 3, and that negative 2 is gonna be a positive number, so it's gonna be equals 5. And we are gonna have negative 5x, and then we are gonna put the 5 to the other side, and it's gonna be basically a 5 over 5. X equals 5 over 5, and x at the end of the day is going to be negative 1 from the fraction that we did.
Yeah.
I don't know if you guys can see it
I
because my
think it
iPad is
looks
kind of
there, but
slow,
yeah,
Mm-hmm.
that did,
but does it make sense?
yeah.
Yeah. So yep. I know we have 2 minutes left, so we're gonna do this quickly. AVA. I'm gonna try to remember. AVA.
Write it down
Okay.
too.
Intercepts will be 0. I'm sorry, minus 1/3 and 2. And the y-intercept is minus 2. So we're gonna start by placing our intercepts. I bet that minus 1/3 will be like here.
Mhm.
Well, it's a little bit by the half, but a little bit here.
Let's see.
The other one is 2, 1, 2, which is here, and it goes like above, below, above. I'm gonna place them here. So it goes something like this: above, below, above, something like that. But um, clear. Oops, sorry.
So it's going to be minus 1/3, right?
Minus 1/3. Oh, also draw the asymptote, which is 3. The lines goes all the way here.
So it's going to be, it was positive 3. do we want to put it on the negative side or no? And this one it stays in positive.
What do you mean? Oh, the other one, the 2 goes positive here.
Okay, because in the previous exercise we put it was +2, but put -5, and we put it on the positive.
Mhm. And
Yeah,
so
but
It would be +3, -1.
it goes something like this. Okay, I cannot draw correctly, but we have less than 1 minute, so the
put it right there.
graph crosses like this. It's not the most straight line. The intercept here goes here. This goes above. This goes below, and this goes like this. So I'm gonna stop this.